Hello, we're cadets of Military Institute of Telecommunication and Information Technologies named after heroes of cruelty, and we are presenting our solution in creating prototype of mesh network of military sensors, aka Internet of Military Things.
While identifying the problem, a number of issues arose that need to be solved to create such a thing as an Internet of Military Things. One of the important things is security, how to ensure safe operation through the network. The second question, the organization of a network of smart sensors, how to do it during joint operations. Also important is the aggregation and processing data from the sensors and their future storage in our records. We need to understand where our devices are, so we need to address the issue of digital identification. The most important thing is to solve the problem of managing devices, creating and adding them to our networks. We need to one ring to rule them all.
IOTA Tangle is an open-source, feeless, and scalable distributed ledger designed to support frictionless data and value transfer. It also provides possibility of creating smart decentralized networks with using smart contracts. We decided to use blockchain-like technologies in cause of speed limitation of classical blockchain model. We used directed acyclic graph named Tangle instead.
This video shows the bottleneck of the classical blockchain.
Directed acyclic graph increases the speed of processing of transactions inside the network. In the demo purpose, we are deployed our private Tangle with a ORNet node. ORNet in the main node of the Tangle, which provide possibility to receive and send transactions inside the network, storing the data about them, search the messages and transactions inside the network, and visualize the state of the Tangle in the real-time mode. Also, it gives possibility to search history of the transactions inside the node. For example, we will give two scenarios for the application of our concept. The first scenario occurs during joint operations by nations. Each of the nations deploys private networks and private tangles and connects them to each other. By establishing rules for the exchange of information in accordance with the restriction of the level of secrecy, one of the nations provides access to only one of the sensors, when at the same time has access to both. In this situation, we see an example of visualization of work when one of the nations has access to only the one of the sensors. Restriction on the level of secrecy allow information to be transmitted in a secure manner without the risk of its leakage. Scenario 2 shows a situation where one nation has deployed a private network and the other only has sensors. By signing sensors through our secret engine and identification service, we provide the ability to collect data from allied sensors to provide greater situation awareness during the joint operations in the region with other nations. Nodes can search for each other, which speed up network deployment and provides tools to control nodes in the tangle of your operation. Instead of auto-peering, you can use a manual adding the nodes into the network. It provides a possibility to add new nodes which need to confirm you're adding into the network. Pollen Analyzer provides your possibility to visualize the state of your network. Also, it provides a possibility to analyze networking between the nodes. Our concept allows you to execute and program smart contracts inside our network. Such tools turn the Internet of Military Things into a smart network capable to execute in previously complex scenarios. One example is the interaction of coastal and marine radars with the Coast Guard system. Thank you for the attention.